So let's solve these together with the less method. I encourage you to stop the video, try to do as much as you can, maybe just identify the variables, and then pause it and continue to stop the video and work on the problems while I'm doing it, and that will help you identify what steps you are getting stuck on. So the first question says, how many moles of gas are contained in 0.890 liters at 294 Kelvin and 99.95 kPa? So again, N is our unknown, so I'm going to put my question mark there. Temperature is already in Kelvin, so I can write 294 Kelvin. It's pretty sloppy. Part of the key of this is doing it nicely. Volume is 0.890 liters, and my pressure is 99.95 kPa. And again, it's important to write kPa because then we have to choose the right R. We have to choose the R value with kPa in it. So, we've done the L. Now I need to find an equation that relates them together. We remember that. That's the PV equals nRT. So I'm going to write that again. PV equals nRT. And some of you might think it's silly to write that over and over again, but I'm giving you 1 out of 4 points just for writing that equation because I know how it's important for this process. So just trust us and write the equation and get 1 out of 4 points for that. The next thing you have to do is substitute that stuff, the variables in. So 99.95 kPa times 0.890 liters equals N. That's again what we don't know. My R value is 8.31 liters times kPa over mole times Kelvin. And then the temperature of 294 K. Now, doing this math, just like we did before for the dimensional analysis, all of these units will cancel, as you can see, when we divide them by each other. They'll be on the top and the bottom, so they're going to cancel out. But I'm not really showing that well right now. But anyways, you do that. Maybe the first step you should do is combine these two terms. Then you want to combine these two terms and then divide off to solve for N by itself. I'm going to pause the video real quickly and do that on my calculator. So if you put those numbers in and then use your algebra skills to solve this, you're going to get N equals 0.36 moles. And again, I would give you +1 for doing this, +1 for doing this, +1 for putting in all the variables. You do the solving of it, and you can use your calculator. Give me the correct answer for a half a point and the number, the right units for the other half a point. And so that's 4 out of 4 points for solving this problem. Let's take a look at the second problem. So we're going to start by reading it. Calculate the temperature of 3 moles of gas occupying 120 liters and exerting 115 kPa. We want to use the less method as well, so we are going to list out the variables. So it's asking us to calculate the temperature. We see that there's 3 moles of gas occupying 120 liters and finally exerting 115 kPa. We know that is the pressure because kPa is a unit of pressure. So that is the first step, to list out all those variables. The next step is we want to choose the equation. And because we don't have changing variables, we just have PV equals nRT, or PV and N and T, we use the equation PV equals nRT, and we put it down there to earn our second point. Now we're left to substitute all these values in. So 115 kPa, 120 liters equals 3 moles times R, and we're choosing the R from up above, 8.31 liters times kPa over mole K. And finally, the temperature is the thing that we have as our unknown. So at the very end, we're going to leave a T because that is our unknown. At this point, you just have to solve for t, so you have 115 times 120 divided by 3 times 8.31 equals t. You gotta plug that into your calculator. So 115 times 120 divided by 3 divided by 8.31, and you get t equals 553.5. We are wondering what the units are. Well, we know that the units of temperature are always K, and we can verify that when we take a look at our R value. It tells us to use K. So that's our final answer, and that would be our fourth point. So we're going to work on a couple more problems next, and there's one more thing we want to show you. I've already done problem 3 for you, and I just added in moles because I forgot the units, and those are the 4 steps. L, let me highlight them, L, E, equation, S, substitute, and other S, solve. And again, you get a half point for putting the units and like a half point for writing the answer. But problem number 4 should be a little interesting. And I gave you a little hint. This is calculate the moles of argon first. So we're going to have to use the fact that there's 20 grams of argon, and we have to figure out how many moles that is before we can even solve this ideal gas law problem. So if you remember, to solve that, and we can do this off to the side a little bit, 20 grams of argon, and if we remember our dimensional analysis, so we have to put grams of argon down here, and we put mole of argon up here. And so we have to look, is there a relationship between moles and grams? And you guys know by now there is. The molar mass. So 1 mole of something is going to equal whatever it says on the periodic table, which should be 39.95, I believe. Sorry, that's a little sloppy, but 39.95 grams of argon. And so we can calculate however many moles by taking 20 times 1 divided by 39.95, and so we get 0.500 moles of argon. Now, the problem didn't give us any more of our variables, except for the fact that it gave us the hint that things are happening at STP. And if you remember, STP is the standard temperature and pressure. So we are going to be using the values that are just considered the normal values. So the standard temperature is 273 Kelvin, and the standard pressure is for the units of kPa, 101.3 kPa. Okay, and we are looking for the volume, so volume is going to be our unknown. You can look up STP if you ever forget that again. Just make sure you're using the right pressure. We'll be using the ideal gas law equation again, substituting our values, 101.3 kPa times volume equals 0.5 moles times 8.31 times 273K. And then you solve for your V just like we did before, and you know your answers are going to be in liters. So I'll quickly do that. 0.5 times 8.31 times 273 divided by 101.3, and you get your volume to be 11.20 liters. Okay, so you can just do the problem below. It's the exact same type of thing. Again, you're given grams, not moles, but you guys know how to take and solve that problem. So pause the video, solve it, and the answer will be there when you click resume. Okay, now that you've had a chance to solve it, hopefully you got the answer of 1.314 kPa. And if you didn't, check your answer and make sure you calculated the correct number of moles and plugged in your values correctly. Now that you have looked at all of the gas laws, the three individual, the combined, and the ideal, you have learned everything we would like you to learn from this unit, and thus you can focus on completing your Schoology quizzes. Please use them as a check to make sure you understand the individual ideas so that any problem that is thrown at you, you can pick out the right equation, set it up correctly, identify the variables, and then solve it. Please make sure you ask each other for help, and then if needed, there are more help videos posted on Schoology.